Okay, let's start. Last class we discussed regarding final exam question January 2022 until question 3. Okay, so today we proceed with question 4. Today I will finish up January 2022. Then I will recap the class. For previous final exam question, I have uploaded in CM for this January 2022 and also May 2021. I will upload more after this. You can try to do the questions. Okay. Now can you see my screen?
Yes, ma'am.
Okay, good. Now this question is related to chapter reactive process. Okay, reactive process, where it mentioned that trichloroethylene. Okay, trichloroethylene, widely used degreasing solvent for machine parts, is produced in a two-step reaction. Okay, two-step reaction in sequence. Ethylene, C2H4, is first chlorinated to yield tetrachloroethane, which is dehydrochlorinated to form trichloroethylene as shown in the reaction below. Okay, here you have two reactions. First reaction is the chlorinated of the ethylene, okay, to yield the tetrachloroethane. Then second reaction, from tetrachloroethane dehydrochlorinated to form trichloroethylene. Okay, this is trichloroethylene. So we have two reactions over here. First reaction, it gives you the heat of reaction. Heat of reaction of that particular first reaction. Then the question also provides you standard heat of formation, HF, of liquid trichloroethylene. Okay, trichloroethylene, which is this one. So this is the HF given. Now question A, I skip question A because question A is related to some theory. You can refer to the questions, the uploaded question. That one, it asks you, wait, I think that the question. That one, it asks you about, it asks you to assess the reaction whether exothermic or endothermic by giving explanation on the energy requirement. So for A, you need to explain something related to bond breakage or formation. Okay, that one, understanding from the theory, you can find it in the textbook and also from the slide. Now, we proceed with question B, which it asks you by using the given data and tabulated standard heat of formation of ethylene and hydrogen chloride, it asks you to compute the standard heat of formation of tetrachloroethane. Tetrachloroethane, this is the one. Okay, tetrachloroethane, which refers to C2H2L4. So this one in liquid form. And the standard heat of the second reaction, H2. Now, standard heat of formation, this one, standard heat of formation, KHF. Now, it wants you to calculate standard heat of formation of this. From the reaction, we can see that tetrachloroethane produced in reaction 1. Okay, it is produced in reaction 1, and it acts as reactant in reaction 2. Okay, from reaction 1, given the heat of reaction. Okay, so from here, using the heat of reaction, you can find the standard heat of formation of tetrachloroethane. Okay, let's do step by step. Now, from reaction 1, okay, the HR is given. Okay, we know that reaction, heat of reaction, the heat of reaction 1 is equivalent heat total of product heats minus total of reactants heat. Okay, so this is the product. Total heat generated from the product, okay, HS minus the reactant. Okay, R is reactant. So, heat of reaction for equation reaction 1 is already given. Okay, now from here, from this equation, you need to arrange the inputs that you have and what are the heat of formation required. Okay, heat of reaction is given. Now your product this side. We focus on reaction 1. Okay, this one, heat of reaction. Heat of formation. So heat of reaction is equivalent total heat generated by product minus heat generated by the reactant. Okay, so your product hydrogen and tetrachloroethane for reaction number 1. What is this about? What is the value of this? What is this stand for?
1.
Yes, Stoic coefficient of, okay, the Stoic coefficient. So H2 HF of H2. Now Stoic coefficient of H2 multiplied by heat of formation of H2, okay, plus this is the product. Now Stoic coefficient of the tetrachloroethane, which is also 1. Okay, this is the product part minus the reactant. Okay, reactant, so we have the ethylene, E2H4, and also chlorine. Okay, 2 of chlorine, heat of formation of chlorine, plus 1 multiplied by heat of formation of E2H4. Okay, so this is product side, this is reactant side. Now, where to get this heat of formation? Which table you should refer to?
B1.
B1. Okay, let's see if you have the heat of formation. Okay, B1. Everyone refer to heat of formation. I cannot share the full screen. I just can share the window. So refer to your own properties table. Table B1, you find out heat of formation for each substance. Okay, heat of formation of hydrogen, you will find it in B1, which refers to the amount of it is. What is the amount of heat of formation for hydrogen?
0.
Yes, correct. Because it is element. The heat of formation for H2 is 0. Okay, find out what is the C2H2Cl4. Sorry, this is the one that we need to find, the unknown. Okay, this is our unknown. So this one will be left unknown. Find out heat of formation of Cl and also ethane. Cl2. Okay. What is heat of formation of Cl2?
Zero again.
Yes, correct. 0 as well. So this is element. Then C2H4.
52.28.
Correct. 52.2. Okay, so from here you can solve the unknown. Now try to calculate what is the rate of formation of the unknown.
Minus 333.48.
Yes, minus 333.48 kilojoule per mole. Okay, that is the first part, heat of formation of tetrachloroethane. Here, this part. Now, you need to find standard heat of the second reaction. Heat of reaction, the second heat of reaction. Try to find out what is the heat of reaction for reaction number 2. Okay, product minus reactant. Your product is the tetrachloroethane, heat of formation of this, plus HCl, then minus the heat of formation of liquid trichloroethane, which is given over here. Sorry, this one. This. Okay, your product will be trichloroethane plus the HCl minus the heat of formation of the tetrachloroethane, the one that you calculated earlier. Sorry that.
It's 35.
Yes. Negative 35.03. Kilojoule per mole. Okay, so this is the final, the second part, answer of the second part. Okay, 2 minutes to digest before we proceed to the next question. Now take note on HR1, heat of reaction 1 and heat of reaction 2. Okay, because that one will be used for next question, which is question C. Question C, by using Hess law, compute the standard heat of the reaction for the below reaction. Okay, using Hess law. compute the standard heat of the reaction for this reaction. Okay, from the previous question B, you are given that from here, from this question, copy here. Okay. HR2 just now we had obtained as negative 35.03. Okay, so this is the main equation given. We need to find the HR for this standard heat reaction, for this third reaction. Okay, using Hess law, which we know from the previous question, from the previous statement, it already given these two equations. Okay, using Hess law, identify what is the reactant and product on the main reaction. Okay, C2H4, Cl2 is the reactant. So from these two reactions, we have C2H4, Cl2 as the reaction. Now this one, C2HCl3 as the product. Okay, we have it in equation 2, H2 and HCl. Okay, so all components, all substance are in their original place, meaning that you don't need to reverse the equation. Okay, so you don't need to reverse the equation. So from these two equations, sum up the heat of reaction. Okay, equation 1 plus equation 2. Okay, leaving the, you get the equation 3. Cancel out this, then you get similar to equation 3. You don't need to reverse any equation. Okay, and you don't need to multiply any equation. Just take the inputs, sum up the total of heat reaction. Okay, so from there, heat of reaction 1 is this, plus heat of reaction 2. Okay, then you will get the final equation, the final answer, the total heat of reaction 3. What you get?
Negative 420.79.
Correct, negative 420.79. Okay, any questions so far? Okay, no question. I assume all of you understand how to read. Now we proceed to D. If 300 mole per hour of C2HCl3 is produced in direction of part C. Okay, part C. Now, using this equation, which involve the heat of reaction 3. Okay. Now, and the reactants and products are all at 25 degrees C and 1 atm. Compute the heat that is evolved or absorbed in the process.
Cannot see the screen.
Huh? Can you see the screen? The rest can see or not?
I can't see it either.
Wait, oh, suddenly it unshare. Okay, now can. Now okay?
Yes.
Okay, good. Okay, again, if 300 mole per hour of this is produced in reaction part Q4C. So Q4C means you need to involve the heat of reaction 3, which is earlier in negative 420. Okay, it asks you to compute the heat that is evolved or absorbed in the process. So heat over here, energy balance, Q plus W equals to KE okay, this one 9 as well, no work done, so Q equals to delta H. Okay, delta H over here, given is in the rate, okay, this is rate and dot. So your Q should be in rate as well. Because since it doesn't mention rate or anything, we assume Q in rate form as well because it gives you mole in rate, mole per hour. Okay, so from here, R3. Convert it in kilowatt. Okay, what you got in kilowatt?
Minus 35.06.
Yes, 35 kilowatt.
Negative 20.
35 kilowatt. Okay. Now, how is the mark distribution for this question? For example, for this question, 4 marks. So, final mark, final answer 1 mark, equation 1 mark, substitution of the info 1 mark. Okay, is 2 marks due to unit conversion. Okay, well, here y2, y2 with correct value of the HR 1 mark, then unit conversion 1 mark. Okay. Correct unit conversion 4 marks. Okay, can? Any question so far for question 4? Okay, now question, we proceed to question 5. What is question 5? Oh, wait, I didn't put the question 5. This is question 5. So question 5, it mentioned that sulfur dioxide is widely used in the food and drinks industry for its properties as preservative and antioxidant. It can be produced from the oxidation of hydrogen sulfide as shown below. Okay, so this is the reactive process. The feed stream contains 100 mole per second of H2S and 250 moles per second of O2. The product gases leaving the reactor at 500 degrees C, assuming the reaction operates at 1 atm. So here, this is the temperature. Okay, for question 1, sketch a completely labeled process flow diagram for the oxidation process, oxidation reaction. Completely labeled. So you must label with whatever info is provided. We have 2 streams inlet. Feed stream H2S, O2. Okay, so 100 mole of H2S to 50 mole per second. Okay, 100 mole per second of H2S to 50 mole per second of O2. Okay, and product gases leaving the reactor at 500 degrees C. Product gases. So what are these product gases?
SO2,
Yes, product gas. SO2 and
O2,
O2 and H2O. Okay, so product gases SO2, H2O, O2. O2, H2O, and O2. How do you know O2 as in the product gases as well? How do you know O2 is in the product gases as well?
oxidation process.
Oxidation process. So we assume oxygen is in excess. Oxidation. Okay, the H2S is the limiting reactant. Okay, so from the given statement, here is the completely labeled process flow diagram. You must show what is your inlet. Okay, you must show what is your inlet, the stream inlet, the stream outlet, temperature, pressure. Okay, for pressure inlet, what is the pressure for inlet?
One ATM,
Sorry, pressure 1 atm. How about the temperature? Correct, pressure is 1 atm.
25.
25. Does it mention anywhere?
Take speed.
What? Sorry, come again?
We can use it as a reference.
Yes. Use it. Assume at STP 1 atm, T 25 degrees C. Okay, so this is to answer question 1. 1 marks for the inlet stream, 1 mark for the outlet stream. 2 marks over there. Okay, for B, with proper assumption and justification. So you must assume and justify. Identify the energy balance for this reaction. Energy balance for this reaction. Energy balance, not yet to calculate the heat. What is the energy balance on this? Okay, so for B, now what is your assumption? Is or are? We know that energy balance is this. This is standard one. Okay, now, what is your assumption?
No work, no kinetic.
Yes, no work, no kinetic energy. Okay, yes, no work done. So W equals to 0. No velocity. So KE equals to 0. No height difference. Okay, so PE equals to 0. Okay, 0, 0. Leaving Q equals to delta H. Now this question, it wants you to identify what is the equation involved first. You must get this correct. Okay. It doesn't stop over there. Q equals to delta H. Now, if you expand, because this involves reaction, okay, reaction process. If you expand this equation, what should it be? Reactive
Extent
process.
of reaction.
Correct. Extent of reaction multiplied by
Heat of reaction.
heat of reaction, yes. Then only this one. Product minus reactant. Okay, so this is your final answer. Should be until here. Okay, now after you get the energy balance correct, then only we can proceed to question C, which here you see 14 marks. Okay, taking the feed and product species at T25 degree C as reference, as what we stated earlier. Okay, 25. Calculate the amount of heat, is the Q, that is added or removed from the reactor for the oxidation process. So it want you to find what is the Q. Now, from the equation we developed over here, we need the HR. Okay, then this one involves the heat of formation for each substance. Okay, so we go step by step. We need to identify what is the HR first. So HR, calculate the HR for the reaction, which it involves using heat of formation in foods. Okay, the product is SO2 and H2O. Okay, SO2 and H2O. So 2 multiply with the HF of SO2 plus 2 The info of HF, you can find it in table B1. Now, try to calculate what you get for HR.
minus 1037.
Yes. Negative 1037.38. Okay, then from here, find out what is the extent of reaction. So now we have calculated this. Now find out the extent of reaction. Extent of reaction, you can use N over V, so any of any element. In this case, we focus on hydrogen sulfide. So N from the equation, the reaction equation above, N given as 100 mole over V is the strike coefficient from the equation over here. This one. Okay, so 100 divided by 2, that's 50. Okay, so we have settled the first part of the equation. Now the second part, which is the total of product and minus reactant. Okay, total heat from the product and reactant. Now to find that part, this part, to find out this part, you need to construct the enthalpy table. Okay, so we construct the enthalpy table. We have substance. Okay, what you have. List out all the substance that you have from the equation. Okay, inlet and outlet. Okay, then from there and in, given as 100, none of SO2 and H2O. So enthalpy in. At reference, so that's why here is 0. Because at reference, T equals to 25 UC. Okay, and out. And H out. There's none of H2S. Okay, this one, I put it as N1, N2, N3. Now, try to find out what is N1, N2, and N3 from the equation given. I copy back the equation over here. I write here. What is your N1, N2, N3?
$100.
Correct. Because same as H2S. Okay, so this N1, N2, N3 equals to 100. Okay, now let's determine the enthalpy over here. H1 O2 gas. Okay, this one we can refer to table B8 for O2. Remember the outlet temperature is 500. 500. Okay, what do you get for H1?
$15.03.
Correct, 15.03. Now H2 is for SO2 at 500 degrees C. This one you need to use table B2. Utility from 25 to 500. H3 for H2O, this one also can be obtained from table B8. Okay, I give you the answer. For H2, you should be getting 22.1905. H3, 17.01. Okay, so using all the inputs over here, subs in the main equation. Main equation, this equation. So Q equals to the standard reaction. Okay. Exam version we had obtained just now, HR calculated. So the product find out from the enthalpy table. You can get it. So this is vector minus vector. So product minus vector. Final values, we should be getting this. Okay, so we are done with previous final exam question, SAM January 2022. Any question?
I missed the question for finding adiabatic temperature. Will it come?
Might be.
For the last chapter, the finding the adiabatic temperature.
Might come out.
Because it's a very lengthy process.
Yes. Okay, regarding this, any question? No question. I want to recap. Sorry, how is this? Okay. I want to recap and brief a bit about the final exam. It appears over here. PowerPoint getting crazy here. Okay, never mind. We proceed with the last part. Okay, as usual, final exam will have 5 questions. Answer all. Try to attend all questions. Okay, if you leave 1 or 2 questions, then it's quite hard for me if let's say you are on the borderline of passing. Then no answers for me to mark so that you can pass the course. Just try to attempt all questions. Okay, at least perhaps write the assumption or write the energy balance, the equation. At least from there, maybe I can give you like half marks, or perhaps you need few more marks to pass. So from there, I can help. Must answer all questions. Okay, I will share with you the course outline. Easier to discuss. Okay. Final exam cover all CLO, which all of these, okay, which means that cover all topics. Now, topic 1 is about the energy, the type of energy, kinetic, potential, all of this. Okay, the introduction to energy balance, closed and open system. Okay, then KLO2 is about non-reactive, which covers topic number 2. Okay, topic number 2. This one Then you need to know how to read the steam table, how to get the infos from there. Then the hypothetical path, how to develop that hypothetical path. Okay, and the specific heat capacity for closed and open systems. If you have changes in pressures at constant temperature, what equation that you need to use? Okay, then changes in temperature and constant pressure, how to find the enthalpy, CPDT. Psychometric chart. Okay, this one, make sure you know how to read a psychometric chart. The chart will be given. Okay, then the inlet and outlet enthalpy table. This one, in most of the energy balance question, you might need to develop or construct this enthalpy table. Okay, make sure to state what is your reference state, because if you state the reference state, get 1 mark. Okay, so do it step by step. In order to answer for energy balance, you need to make sure the material balance is completed. Then reference state, construct your enthalpy table. From there, find the mole or mass and enthalpy required. Then subs all into the main equation. Okay, the phase change operation from liquid to vapor, you must involve the heat of vaporization. Mixing and solution. Okay. Then topic 3, which is the reactive process. The reactive process here, in the slides, there are 3A and 3B. Okay, 3A is the different approach of heat of reaction. You have Hess law, you have heat of formation, and you have heat of combustion. Remember, the value of heat of combustion is applied for combustion process. Okay, if in appendix B1, there's HC. So HC here means heat of combustion. When this particular substance or compound undergone combustion, it will produce this amount of heat for combustion process only. Combustion process means this one react with oxygen, producing CO2 and H2O. That is the only product. Okay. Then general energy balance, the heat of reaction method or heat of formation method. It is one when it involves reactive process. Then comes the final part of chapter 3, which is the adiabatic reactor. Okay, adiabatic reactor, remember Q equals to 0. The T is the highest temperature that there is no heat transfer. Means that T out is unknown. From there you need to find out. It is lengthy, but it might come out in the final exam. So just be prepared. Then fuel and combustions, the combustion process. Fuel react with O2. Products is CO2 and H2O. Adiabatic flame temperature is the same as this one, adiabatic reactor. Adiabatic reactor, Q equals to 0. Adiabatic flame temperature is the outlet temperature. The T adiabatic when Q equals to 0. Okay. Practice all the exercises that we did in the class and also the examples in the textbook. make sure you show the steps of your calculation. Okay, and then make sure you know how to use the calculator. Set the equation to find the T adiabatic perhaps, and then set equation to find the unknown, dp dt. Okay. I think that's all. Okay, you will be given Appendix B as your reference during the final exam. Appendix B. If, okay, let's say if you find out there is no table or wrong table, please raise up your hand and mention to the proctors in duty. Okay, I will go there in the morning. So I will go there at the earlier of the session to make sure they provide you the correct properties table. If you notice any missing pages, please let the proctor know. Okay? Because there are once it happens, not enough pages, so the student cannot answer. They need to photocopy the missing pages again. Okay? Okay, I think that's all for energy balance. Your internal marks I will release by this week. I will set for midterm and test paper collection on Thursday. Okay, Thursday no more class, you can proceed with your assignment. I have moved assignment to Thursday. Okay, you have 2 more days to submit. You can collect your midterm and test paper on Thursday, perhaps around our class is morning, right? So before 11 a.m. Because I have class at 11, then in the afternoon session I have proctor duty. Friday I'm not available. Okay, if you want to collect, you must come on Thursday before 11. Okay, any question? Don't ask me what question will come out. Any question before we stop? No question? Okay, so no question. That's it for our class this semester. All the best to you. I pray for all of your success and all of you can pass the course. I don't want to see you anymore in next semester. In energy balance, in other course, no issue. Okay, so all the best. Pray before you answer. Okay, that's all. Thank you. You can leave the class. Yes, Peter?
No, accidentally pressed.
Okay. Okay, if you haven't scanned for attendance, you can share the screen again. For those who haven't scanned the attendance, you can scan now. Okay, for the rest, you can leave the class. All the best. Good luck.